This puzzle is called Foggy Ninefield by Albin Bernhardson, I think. AKA Chainsawklitten. Got it from the Sudoku Testing Submissions channel of the CTC Community Discord. Let's take a look at the rules. So Fog of War, you might have noticed, most of the grid is covered in darkness. Placing correct digits in cells will eliminate more of the grid. So if we placed a 4 here and it was correct, then all of these would be lit up. All the yellow cells would be lit up. Yep, there we go for that. Killer. Digits must not repeat in a cage, and the values must sum to the given total. And the given total is always in the uppermost leftmost cell in a cage. So let's look at this first. So if there was a cage right here and it summed to 20, then the yellow 4 cells would sum to 20, and the 20 would be right here. Now, in a slightly more complicated thing, we could do something like this, and then that's more than 9 cells, so maybe 1, 2, 3, 4, 1, 2, 3, 4. So something like this would have the value here. Something like this would have the value here, because it's the uppermost and then leftmost cell. So you can get kind of complicated with the cages, but they must sum up to whatever the value is, and they must not repeat. Digits must not repeat. And then the thing that's going to let us get into this puzzle a little bit, because we don't have any of the other stuff yet, 9 sweeper. All cells which correctly show the number of adjacent 9s, including diagonally, are marked with circles. So here's a circle. This circle says how many 9s are adjacent to it. And it's bolded in the description in the post in Discord that all cells which correctly show the number of 9s. So if we found out that this was a 9, or if we found out, let's say, 1 second, stop. This is a 9, and this was a 1, then this 1 would have a circle around it. If there was no circle here, then this couldn't be a 1, assuming, of course, there's no other 9s around, but that's what it means, is that there's a negative constraint there too, that it's not just some of the possible cells that work or have circles, but all of the cells which work have circles. In the post on Discord, they said, Albin said that it was probably 3 out of 5 difficulty. If you want to give it a try, I'll put a link to the puzzle down in the description. Let's give it a go. So, well, this can't be a 0, because 0 is not a valid digit. So, at most it could see 1 9, because you only can have 1 9 in the box. So this must be a 1, and there must be a 9 in here. But let's actually remove that 9 for a second so we can see this. Actually, 1 second. Let me see. I think there might be a setting for this. Is it large digits? Yeah, there we go. So now we can see both. So if we try to put a 9 in this 13 cage, let's see what, at least the 13 cage goes like this. It could have more, but at least this much. If we put a 9 in here, what would we need? We would need 9, a 1, and a 3. That's the only way we could have it work. But we've already used the 1 in the box, so 9 couldn't go in here. If we tried to extend more, a 9 definitely couldn't go in there, so this must be a 9. Okay, so we have a 14 cage that goes at least this far. Now, one thing I did notice about this 13 cage can't go any farther. Because if it tries to take 4 cells, it must have a 1 in it. And this 1 would be blocking out every possible cell in the cage. So this must be only 3. If we try to make it go to 5, the minimum value of 5 digits that can't repeat are 1, 2, 3, 4, 5, which sum up to 15, which is of course greater than 13, so it can't be 5 long either. Even though something like this would allow us to put a 1 where my mouse is, but it couldn't sum up to 13 either. So this is the full 13. 14 could go farther. Let's do a little bit of math though. So a full region in a Sudoku has the digits 1 to 9, same as a row or a column. If we add up the digits 1 to 9, that is 45, just 1 plus 2 plus 3, up to 9. That equals 45. So if this full 3x3 sums to 45, we have 10 here with a 9 and the 1. We have a 13, so this is 23. And this sums, so 45 minus 23 is 22, which means these 4 digits add up to 22. Which means, could we extend this any farther? If we extended this here, let's say, then these would sum up to something less than 14 because we would need to sell here, and this whole thing adds up to 14. So this would be 14, and then we would need something here that I don't think works. Let me go back here. Let me do this math again. 27, yeah, so if this is the full red, then this would be an 8. If we tried to extend the red farther, in any direction, this way, or down here, then, or I guess down here definitely wouldn't work, because that would only be 37 for the whole cage. So we tried to put a red in one of these two spots. This digit would have to go up, but we can't make it 9, and we can't make it bigger than 9, so 8 is the maximum, and we can't go any farther, so this is just an 8. Okay, so now we have a 23 cage. There's only one way to make 23. That's 6, 8, 9, and this 9 is going to resolve some of that. Let's get rid of some of these colors now that we don't have to kind of guess. This is a 12 cage, and it must be the full 12 cage. Again, because if we tried to make it 5 long, that would have to sum to 15 at a minimum. We have 9s down here somewhere, although that's not probably super helpful. 8 can go in a couple places. Oh, 9 sweeper. Okay, that's what I need to think about. I just looked back up at the rules. We don't have any circles next to this 9. Although this one... No, we could have a 9. We have a 9 somewhere in here. We can't put a 9 in a 4-digit 12 cage. So there's a 9 somewhere up there. But neither of these can be 1. Because none of these cells can be... Sorry, well, none of these cells could be a 9. Because this 9, of course, rules out all of this, and this 9 rules out this, and then the 12 cage rules out the rest. So this sees exactly 1, 9. And this sees exactly 1, 9. So if this was a 1, we would need to have a circle there. Which means the 1 must be over here. Because it can't be in row 9. A 12 cage in 4 must have a 1 in it, though, which means this must be the 1, because this can't be a 1, and these can't be a 1. Because of these pointing 1s up here. So that's a 1. We now have a 7. With the 7, oh, I guess we don't need to color that anymore. Could this be longer? Could it go over to here or down to here? I don't immediately see why that wouldn't work, so let me just mark that. Oh, so this 1 must not be... is not circled, therefore there must be another 9 next to it, which means one of these 9s must be next to it. Okay. Oh, this can't be... This has a... Okay. This is what I need to think about. So this 7 cage has a 1 in it. If it was just a pair, it would be 1 and 6, but we've already used the 6, therefore it's not a pair. It must be a triple, which means this must be 1, 2, 4, and one of these is also involved in that, but we do not know which one is involved at the moment. Did I? Oh, that doesn't work. That doesn't work either. 1 second. Okay, sorry about that. Just wanted to open up another window so that I could look at cage options. Let's open up Notepad. I think I just put it up there. Yeah, good. So 12 and 4 has 2 options. Okay. So no matter what, we're gonna have a 2 in this 12 cage. If that 2 is in one of these 2 cells, we're going to have a problem. Because a 2 in here would rule out 2 here and out here. So neither of these are 2s, so this is a 1-4 pair. One of these must be a 2. But if this is the 2, we're going to run into the same problem because this 2 rules out here and here. So this can't be a 2 either. This must be a 2. Which means the 2 is in one of these. We have ruled out 4 actually, so it can't be 1, 2, 4, 5. It must be, whoops, it must be 2, 3, 6, and this can't be a 2. And these can't be 6s, so this is just the 6. This is a 3, this is a 2. Okay, I don't think we need Notepad anymore, so let's just hide that for the moment. This is a fairly big cage here. 1, 2, 3, 4, 5, 6 at a minimum. Actually, at a no, it could. No, it can't even come down here because this is. Whoops, not there. This is a 22 cage. This can't get any larger because if it went up here, then this dotted line wouldn't be here, and if it went over here, then this dotted line in the corner wouldn't be here. So I think this is the exact layout of the red cage, and this is the exact layout of the blue, or sorry, of the green cage as well, because if green extended down here, what am I trying to say? If it extended down here, then this dotted line wouldn't be here. So I think we have those cages figured out. We do know there's a 2 down here. What is this? This is 8, 7, and 5, just to finish up the box here. We've already taken this into account because this is not circled, therefore there's not a 9 next to it. Or sorry, therefore there's a second 9 next to it, sorry. No, I think this could, ooh, excuse me, this could be 1 9 like this. I was trying to think if we could rule 1 out of both of these cells, but I think we can rule 1 out of this cell at least, for whatever that's worth, because we would end up with a 9 next to it no matter what, and it's not circled, therefore that wouldn't work. But in this case, this could be 1 9 specifically like this. And this is not a 1 either, I guess, because 9's going to end up next to it. Whoops. But this could be 1 9 like this. Oh, no, I guess 1 can't be in the bottom row. What am I talking about? So 1 could be in any of these cells. That's not super helpful. Can we figure out this, maybe? Let's look at the options for 14 and 3. Whoops, 14 and 3. There are a lot of options. Let me just paste it in here and then show Notepad again. And let's make it so we can actually see all the options. Okay, so we can't have a 1, 9, or 8, so let's remove 1, 9, whoops, 9, 8. It also can't have a 2. Oh, darn it. That is, so I guess there is a 3 in here. It's either 3, 4, 7 or 3, 5, 6. But a 3 at least. And I guess that makes sense. This will have a 3 plus an 11 pair, either 4, whoops, either 4, 7 or 5, 6. And this will have a 2 plus the other 11 pair, either 4, 7 or 5, 6. And the 5 would have to go there, and the 6 could go there in that case. Actually, in fact, this is a 5 or a 7. This is a 2, 4, or 6, because this puts the 5, 7 up there. I don't know if that's helpful or not. Okay, 4, 7. So we know 1s are up there, 6s are up there. 9 is somewhere in there, that doesn't help. 28 and 6 is not very restricted. I don't think if we could rule 1 out, then it would be very restricted. But I don't think we can do that. I think, like, 1 is probably in here, because it can't be here, as we said before, but it could be here. Is it something with a 9 sweeper going on, maybe? I don't see what it would be. I think only the ones matter at this moment. So this is 1, 4, 5, 7 left in the row. This can't be a 1 because again the 1 will be next to the 9 and would have to be circled, but it's not circled, therefore it's not a 1. Huh. There's something going on here that I'm not picking up. So what's the other digit down here? There's a 3 is down here as well. And I guess we know an 8 is up here. Does that? Not really, I don't think. Because we could still do 5 cells minimum, which would be 15. Plus an 8 is only 23, which gives us 5 digits of freedom. Which is a lot of digits of freedom. It must be this 22 cage, and there's just something I'm not seeing here. So let's look at the options for 22 cages in 5 cells, and maybe there's just something that will stick out to me. Like, oh yeah, duh, something just doesn't work. I kind of feel like that's not the case, but like if we could rule 1 out, that would be hugely helpful, but I don't see how we can. Okay, let's look at these again. So it can't have a 2. So we can actually rule out a 2. Therefore, that's what it is. It can't have a 2. None of green cells can be 2. Therefore, it must have a 1. Yeah, that's what it is. So neither of these can be. Oh no, wait. This is circled. Right, because I didn't have this revealed. I just had it colored green. So 9 is in one of those 2 cells. Okay, that's big. So this could be a 1. Do we have to have a 1 in 28 and 6 cages? Let me just quickly look at that. No, it could be 2, 3, 4, 5, 6, 8. So it doesn't necessarily have to have a 1. If it did have to have a 1, this would have to be the 1, but unfortunately, it does not have to have a 1. Let's see. So this is... Oh, and it must also have a 3, actually. So this is not a 3. 3 is over here. Oh, that makes this a 4, this a... Whoops. This a 4, this a 1, which means this is not a 4. Unfortunately, that doesn't give us any new information, I don't think. I guess it means this is not a 9. Does that matter? I don't really think it does. It's not a 9 because this would be circled 1 if this was a 9. I'll keep that in mind for the next, when we look at the 28 gauge. Okay, so this has to have a 5 or a 7 in it, therefore it's not here. Oh, I accidentally typed a Z in there at some point, I guess. Okay, so it can't be this, because it needs a 5, 7, and 8. It needs basically 2 of 5, 7, and 8. We could put 5 into one of these cells if it was the highlighted one over here. if it was this one, we could put the 5 into one of the two options, or one of the two selected cells, but we couldn't put the 4 anywhere. Or we couldn't fill the other cells, what I mean. Let me go through, yeah. Another way to look at that is 3, 4, and 9 would have to both, or all three would have to be in these two cells, and that obviously doesn't work. So it's, 9 is not in the, whoops, 9 is not in the cage, so that's a 9. We don't have an 8 in here. This is a 3, 6. This, okay. So we can, let's just hide notepad for the moment. So this 6, these 6s look over. This is not a 6. This must be a 7. This must be a 5. This is 7, 5, 8. This is 3, 5, 6. That's what I said. Oh, what did I do wrong here? Oh, this is not a 5. This is a 4. Yeah, 4, 7, 8. Okay, what does that add up to? That's 19. So this has to add up to 9, which is very restricted in 3 cells. Without a 4, it must have a 1, which means this is a 1. This adds up to 8 then, because we have 20 total. So it's either 2, 6, which it can't be, obviously. There's a 6 right there, or 3, 5, which goes like this, 3, 5. Let's get rid of this color. This must be the full cage, because if this went up, then the 15 would be up here. So that's like that. 9 must be in one of, no, I guess one of these 3 cells. 5 is along here, that's not super helpful. Oh no, 9 must be in one of, yeah, 9 must be in one of these 2 cells, because we have these 9s looking over, because it must be next to the 1 to make this not a 9 sweeper identifier cell, because it's not circled. There we go. So this is actually going to be 9, whoops, did not mean to highlight that center cell there, or center box there. So this is 924 to add up to 15, because it can't be 1, 5. That makes this 6, 8, 7. Now this cell could be up to 4, I think. Could it actually be up to 4? How many 9s could we fit into this? I think it's up to 3. So we could fit it, one of these is definitely going to be next to it. We could put one up here and one over here as well. So up to 3. But it can't be a 1 because we've already put a 1 all over. So this is a 2 or a 3. And actually we have a 2 in the row, so it can't be that. So it must be a 3. And then we have a fairly large cage over here. But this 3 is actually going to be super helpful. We need a 9. One of these is going to be 9, obviously. Then we need a 9 above it, which I think must be in one of these 2. And then we need a 9 to the right, which must be here. Because if we go here, it rules out the one above it as well. And we can't do that, obviously. That would be bad. So we get this 9, and now we have 1, 2, 3 9s next to it. Oh, we have this 3 here. We can do a little bit with that. Puts a 6 up here somewhere. I don't know how helpful those lines or those markings up here are going to turn out to be, but there's something. It's hard to know what you need to pencil mark in Fog of War puzzles, because like every once in a while there's just like, oh wait a minute, this is just a given 2 based on some weird logic that isn't readily apparent, and then that gives us the next piece of information. So I just end up like coloring a lot of options. So we know one of these is a 9, but we don't know what this sums up to. Oh, we know this is not circled, therefore this is a 9. Because currently, if this is not a 9, then this 1 accurately counts how many 9s are next to it. So it needs another 9 next to it, which means that's a 9, which means this is a 9. Ooh. Which means this cage ends over here, which means this needs to come up to this row at least. 1, 2, 3, 4. 6. So it's in one of these two cells. It could go like this, or it could go like this, or I don't know, any number of weird things, but it has to come up here at least one cell in order to get the digit, or it could even come up all the way up here. I don't know how to mark that. Let's look here. This must be a 1 or a 2, because it could at most get 2 9s next to it. This can't be a 9 anymore. Oh, I guess I was going to say this is ruled out from being a 9 because of that 9, but we already had a 9 looking over there, so that didn't help. This is accurately counting. Not accurately, not accurately, not accurately. If this was a 1, would that cause problems? If this is a 1, no, the 9 could be down here. No, the 9 could be right here. If this is a 1, then this would be a 2. So we would need the 1 to not be correct, but the 2 to be correct. So if we put the 9 here, the 2 would be correct, but the 1 would not be correct. Yeah, darn it. Let's see if we could rule 1 out of there. I don't know if that would have been hugely helpful, but maybe a little bit helpful. I guess we need a 3 over here as well, so the 3 must be in this column as well. Oh, you know what? 2 must go along here in this box. I should have seen that earlier. Which means this can't be a 2, so this is a 1. And 2 goes along here. Now, green does not come up here, so I think it must go there. 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah. So the only way we could get up to this row is by going exactly like this, and it's going to have every digit from 1 to 9 in it. Because there are 9 cells in the cage and it can't repeat. This also has an 8 over here. So what question do we need to be asking? Okay, oh yeah, where can 9 go in box 1? That's the question. 9 can't go along there, and it can't go in green, and the thing that I missed, that was the first thing I looked at, but the thing that I missed was we can't have another 9 next to the 1, so none of those can be 9 either. This is the 9. Which means this is not a 9 and puts a 9 right there. Which makes this a 1, because it can't see any other 9s possibly. Like, or, I mean, it's impossible for it to see another one. I said that kind of a weird way. And this is a full cage here. We don't know what that is, though. Is that too close to the... I'll make it blue. I think that's more different, the most different than the 2 other colors. Now this, whatever this is going to show up in one of these 2 cells. But I don't think we know, I don't think we have enough information. I guess this can't, or no, there's one digit that doesn't show up in blue. Oh, darn. I was going to say this can't be a 6 because we need a 6 in blue, but we don't necessarily need a 6 in blue, do we? It's only 8 cells large, so we could have one digit sitting out. And that could be the 6. Okay. Now let's look somewhere else. We need a 1. Another 1. Oh, that's where we need to look. 1's over here in box 4. Must be in green, therefore this can't be 1. Therefore this is 1, and then that's 1. Let's get rid of that color a little bit. I don't know why I said a little bit. You can't a little bit get rid of a color. Oh, this can't be a 2. I've had that marked, but that's not true. None of these could be 3. Is maybe 3 limited in here? Not really. Fours in here. Look, maybe we need to look at 9 sweepers again. Let's look at 1s and 9s. 1s, 9s, 1s, 9s. I think we've done all the 1s actually. Oh, this is just a 9. Because we have this 9 up here that we've just been sitting there. I don't think any useful information could be in here. Because it can't be circled because there are no 9s adjacent to it. Yeah, that's basically... That'll just get filled in whenever... Oh, this can't be a 6. How long has that been sitting there? Darn. I mean, it's not super helpful, but it's something that I should have noticed like an hour ago. I've only been working on this a half an hour, but I should have noticed it an hour ago. 6 isn't one of those, I said that. Not necessarily in the cage, though. What about this column? It's 2, 4, 7, 8 left. That's not helpful. Maybe we look at... Oh, we have very few 2s, actually. 3 must be up there. Oh, this can't be a 2. Oh, I was looking at... I thought about 9 sweepers, but I didn't think enough. This can't be a 2. If this was a 2, it would have to be circled because there are 2 2s next to it. Sorry, 2 9s next to it. So this is a 2, which puts a 2 down here. Let's look at 9s again and see if I missed something else. This can't be a 2. I did miss something else. This can't be a 2 because it's next to 2 9s. It would have to be circled. This could be a 2, this could be 2. Let's look at 9s. This can't be a 2 because it's, again, next to 2 9s, so this can't be a 2. Therefore, this is a 2, this is a 4. We have a 7 8 pair. This is a 2 3 5 in the column, so this can't be 2. This is 2. We've now revealed a little bit more. I was going to say we revealed all of it, but actually we have not revealed all of it yet. So we have 8 cells adding to 39, meaning we miss out on 6, so this must be the 6. Whoops. And this is 4 7 8. This digit is the same as this digit. And it can't be a 4, so this can't be a 4. Which means this is the 4. So this column is 5 7 8 remaining. Okay. So we have a 2 in this cage now. Where is this causing issues? If at all. Oh, this can't be a 2. It can't be there or there or there. That doesn't quite help. One of these must be a 4 because we have this 4 looking all the way across. 1 2 3 4. We don't have a 5 looking in yet. What's this? This is 5 6 7 8. It's almost helpful, but I don't think quite helpful. Because I'm not sure... Oh, where can 3 go? That's something. Where can 3 go in this cage? It can't go here because of the penciled 3s, or actually, this 3 means it can't be there. That's already a 2. This 3 means it's not there, therefore 3 is in one of these 2 spots. That's not a 3. Four is in one of those 3 spots. Okay, let's just start looking at digits because I feel like I've been missing some Sudoku. 2's down here, 2's down here, 2's kind of in the corners. 2's in the corners over there. 3 goes across the middle. Actually, it's not across the middle because we have these 3's looking down. 3's up there, 3's, yeah, okay. 4's, not very many 4's. We really don't have very many 5's. One of those is a 6. If this is a 6, this is a 6. Does that cause any problems? Because this can't be a 6 because of that. So that would put a 6 here, and a 6 here. That seems fine. What about, if this is a 6, then we need a 6 in the cage, and it must be here. Which then puts a 6 in one of these 2, actually puts a 6 there, and puts a 6 here. So no matter what, this is a 6. I guess, yeah, let's look at that again, because that does reveal this a little bit. If this highlighted cell is a 6, I guess we could, if green is a 6, then this must be a 6 because it cannot be in the cage again. Then this is a 6, then this is a 6. If green is not a 6, if the first green is not a 6, this must be a 6, and we'll make it pink. Which means we need a 6 in this cage. Oh no, what, this could be a 6. Never mind. Never mind, I did not... Yeah. This 6 does not force this 6. Because this could be a 6 to fill up the 6 in the cage. I still have all the 1s. Let's look at... I think I have all the 9s. No, I should. I have 1 8 and 1 7. Maybe it's a 9 sweeper thing that I'm just not realizing. Let's look at bunched up 9s and see if there's like a 3 that could see... Like this 9 can almost be ruled out. No, I don't think so. Not quite, not quite. Sorry if you can hear my chair, by the way. I've said this before, but it is a very loud chair. It likes to make appearances in these videos. Even though I feel like I'm sitting almost perfectly still. What am I missing here? Let's just take a look at the rules. Fog of War, not missing anything there. Killer cages, not missing anything there, I don't think. And 9 sweeper, I think I've basically done everything with 9 sweeper, unless there's something really silly that I'm missing. Let's look at 2s again. I think this is all that's left of 2s. Let's highlight the actual 2s as well. Are there any spots here that see 2 9s that are not circled? In fact, none of the 2s are circled, so are there anywhere here that could see 2 9s? I don't see it. If there is one, I do not see it. So I think 9 sweeper is done as well. I've looked at 1 2s and 3s. Yeah, I looked at 1 2s and 3s. And I've already finished 1s. Okay. Maybe I need to color 7s and 8s. That's something I... Oh! I'm dumb. This can't be a 5 because I have a 5 right there. This is a 7. Yep. I said I... As I was saying, I think I've done killer cages. I was thinking, you know what? I wonder if I'm missing something with a killer cage. I should take a look at that again. And I was. So this 7... This 8 makes this a 7 8. Okay. Let's look at this row. We need a 2, 4, and 7. This can't be a 2. This can't be a 7. So we actually have a 2 4 pair here. Is that right? 2 4 7. That's a 2 4 pair. So where do we put 4 in this cage? Can't be along there because of the 2 4 pair. Can't be in row 4 because of the 4 there. So this is a 4, this is a 6, which is going to give us a little bit. Maybe not as much as I thought. I was going to say it's going to give us a lot, but maybe not. Oh, we now have a 3 7 pair, so this can't be a 7. 4 2. Oh no, now 2 is in one of these 2 spots. I guess that doesn't help immensely. This is 2, 3, 5, 7 across the top row. This can't be a 7. This can't be a 2. Neither of them can be a 3 because we have 3's pencil marked into the cage there. So close to giving us something, but not quite anything yet. Yeah, this 3 goes up there. We said that. We need a 6 in the cage, but the 6 could go in either of these two spots. What about this column? We need a 3, 5, 6, and 8. Well, let's just delete that. Okay. 3, 5, 6, and 8. It's easier for me to just type all the options in and then remove them rather than trying to do it while I'm typing it. Yeah, this is just a 3. 3 5, 6, 8, so this is a 3. Which means this is a 7, 3. Not a 3, not a 3. What is this? A 4. It's a 4 there. Finishes off our 3s. Nice. This is 5, 6, 8 with a guaranteed 6. This is 5, 6, 8 as well. And actually, neither of these can be 8. This is a 5 or an 8, so we actually have a triple here, so this is just a freebie 7. And this is a 5 or an 8. Okay, I think this is going to resolve everything. Do I need to color this, or can I spot something easy? Well, let's just color it. We know these 3 are different because they're all in the same cage. So we can do like green, blue, and red, I guess. Or let's do, yeah, let's just do those. So now this one sees blue and green, so it must be red. Which means it's not 5 or 6, because if it was 5 or 6, it would rule out both of these. Because we already have red in those columns. So red can't be 5 or 6, so this must be 8. So let's remove those. Oh, and then that's going to just resolve everything, isn't it? Okay, we didn't need to do a bunch of coloring, just a little bit of coloring to give us a nudge in the right direction. And there we go. Yeah, about 3 out of 5 difficulty. That one spot where I was just stuck for a long time, that was a little annoying because I was just being dumb. Actually, all my stuckage in this puzzle was with this 22 cage. The first time I was stuck, I just didn't realize that it basically had to have a 1 or a 2 in this cage. For some reason, I thought it was less restricted than that. And since it couldn't have a 2, it took forever to realize, oh, wait a minute, it must have a 1. The second time, I just didn't rule out the 5 and 7 for like 10 minutes. Whatever. Oh, that was weird. Does it every time you remove a color, it tells you solved the puzzle? That's a little weird. But that was a very fun puzzle. Thank you very much, Foggy Ninefield is the name of the puzzle. Thank you very much, Albin, for that puzzle. That was great. And thank you all for watching.